Greetings, my name is Luke Oates-Pena, and I am proud to call myself the current president of the second student chapter of PCI, operating at California State University, Sacramento. As you may well know, during the fall of 2018, Sacramento State students were treated to the first ever Precast Bridge Design Studio in the nation. Naturally, me and my fellow officers were among the first to enroll. I was happy to do my part and see Precast get the seat at the table we all know it deserves. Having now completed the Bridge Design Studio, it is my pleasure to share with you some of the details of the class that we enjoyed so much. The Fall 2018 studio included a PCPS class for CE students and a Precast seminar series for both CM and CE. As a civil engineer in training, my class was assigned the job of designing a multispan precast prestressed concrete bridge per AASHTO LRFD standards. The class of 15 students was further broken up into 3 separate groups, with each group responsible for designing a unique girder type. Team 1 was assigned the I-girder, Team 2 the wide flange, and Team 3, my team, was assigned the bathtub U-girder. Initially, it seemed like a tall order, but we had industry there to help us along the way. First off, Jim Ma and Dr. Lowe from Caltrans provided excellent support throughout the entire duration of the class, answering questions and guiding students as they went through their design. Additionally, each team was assigned its own unique industry mentor. Wes Sennett from MGE represented the I-girder team. Bob Fish from TY Lin assisted the wide flange team. And lastly, Jason Hickey from Mark Thomas was my industry mentor, assisting the U-girder team at every stage of design. We appreciated the help, as there were several deliverables that needed to be completed. Each team was required to produce the following: a full set of plans, design calculations, quantity takeoff and cost estimate, and a construction sequence featuring a working day schedule. Fortunately for us, our aid from industry had only just begun. Many design professionals from the precast industry stepped up to help us students, mentoring us and teaching us, offering plant tours, software, and all kinds of other mentorship. But don't just take my word for it. Allow me to show you all of the amazing opportunities offered to us students through the Precast Bridge Design Studio.
diaphragm. We've got intentional roughening of the top surface.
Take a look, guys.
For the this is where the deck pour is going to interface with the girder.
Especially the bridge design team.
Now, if you notice, on this job, you notice we've got these smooth margins troweled along the flange tips. Has anybody got a idea why that might be? So the answer is, what are we actually going to be putting on here in the field? These are going to be, this particular bridge is using the stay-in-place deck panel. And so you want your camber strips on a relatively smooth concrete surface to profile your PDPs.
Hello, we are UCAST Engineering, and we're going to talk about our project, which is designing a precast prestressed bathtub girder with 3 spans. So in this presentation, we're going to go over the introduction, which is the overview of our project, our results, design process, construction, cost estimate, also the conclusion and lessons learned at the end. So our general project location is in Lincoln, California, and so with respect to Sacramento, it is there, the yellow circle. And as you can see, it is west of the Highway 65, and in red you could see the planned extension of Whitney Ranch Parkway, and in yellow you could see the bridge, and also the blue signifies the railroad that it will be spanning. And so this is our design here. We're going to have a 3-span bridge with 100-foot spans. We're also, you could see there, all the lanes and the median right there in the middle. And also, we calculated about 86-foot width of the bridge. And the water main will be housed there in the median.
Took in using the software, as it was also part of the learning for us in this class, which was using that PG Super software. And first we began by sort of creating a bulkier section. We originally started with 10 girders for a typical section and a much thicker deck, and we began to input strands directly for a total of 48 in our beginning design. After which we began to then make our design more efficient. And with this, you can see sort of a schematic of the program in which it shows our straight strands, debonded strands, as well as our total number of strands on the right, and on the left is what we had previously. And here's basically a schematic of the cross-section of our final girder that we designed, or a typical girder that we chose to use for the design of this bridge, in which we only debonded 8 strands out of 52. And we ended up including 4 strands at the top of each web to essentially accommodate a little bit of the load during transfer. Eccentricity. It was learned that it could be a blessing or a curse. I mean, a very high eccentricity could essentially help you or benefit you at your moments at mess span, but it could also really harm you at your transfer lengths for tensile stresses at your top of your girder, which could essentially damage it and damage your structure as well. And with that, that should wrap it up. And thank you so much.
Thank you. I believe so. I mean, I believe I did have 10 days for that estimate. If I did make any mistake, this is a learning opportunity, so please tell me. I'm not perfect. And now, a few words from the industry mentors who made this all possible.
Just you take this class, you really need to appreciate Professor Matsumoto's effort. Okay. So I know you are tough students. Sac State, if you're not tough, you don't take Professor Matsumoto's class. I understand that, And also make it brave. Okay. We see your capacity today. We see your potential today. And one message for you: Cartran is hiring. So submit your resume. Okay. forget about the consultant.
Right now, today, we have 15 students that have more than a seat at the table. I mean, this is way better than I could even imagine. I'm going to go back to the foundation and say, Sac State has done an outstanding job. We have 15 students in one semester that can come into our industry and be a viable part of our industry right now, especially in the bridge work. Thank you very much. It's
Thank you.
outstanding.
Thank you, Glenn.
This is the Richmond San Rafael Bridge. I'm sure you're in. This is another seismic retrofit and an actual causeway replacement on the north end, but 1,212 pieces of jackets and 22 pile cap assemblies. Again, the beautiful crystal clear San Francisco Bay water, we had to come up with some kind of a drawing to show what was actually happening. And these, what we call bow tie segments, actually stiffen the bridge in the longitudinal direction seismically, but then these jackets actually stiffen it transverse to the bridge. And so it was a seismic retrofit to bring the bridge up to current standard. So these are the shapes. This is the small bow tie. That's the big bow tie. Give you a scale. That's our carpenter. We could never find where he was, but anyways, go Sac State.
Well, I'm gonna say something. Number one.